Hi guys, Luke Hetrick here with my unit circle project. So obviously, it's a snail. Pretty cool. So, important points. So some quick information about the unit circle. So to start off with, we're going to go over some of the important, not some of, all of the important points on the unit circle. So if you look at just the first quadrant, which is this quadrant right up here in the upper right corner, you have obviously 0. While in degrees, you have 0, 30, 45, 60, and 90, which are the most important quadrant, or the most important points. These points are really important because they work well with the right triangle ratios that you learn in geometry, which are the 30, 60, 90 triangle and then the 45, 45, 90 triangle. So these points allow you to calculate some stuff really well based on those ratios from those triangles. Some other, and then those just continue around. So then you have 120, 135, 150, 180, and then all the way around. So quadrant 1, 2, 3, 4. Okay. So the other thing mathematicians use to measure angles in circles and on the unit circle especially are radians. Radians are around a circle in usually units measured in relative to pi, because pi works out nicely, but technically it doesn't have to be pi. So as you start at 0, you have 0 radians, pi over 6, pi over 4, pi over 3, pi over 2, and then you get pi over 3, or 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, so pi is 1/2 circle, and it keeps going around until you get back to 2 pi as one full circle. Okay? So what is a radian? So like any other measuring unit, there are multiple units used to measure, and they all have their own functions, such as Fahrenheit, Celsius, and Kelvin for temperature. Fahrenheit works well for the average American because it puts 0 as a cold temperature that's not good to be outside, and then it sets arbitrary points for other temperatures. Celsius works well because it's at 0, it's freezing, boiling at 100, so that way you get a nice easy, you learn the important points of temperature easily. Kelvin works well for scientists because absolute 0 is when life shuts down because it's so cold, and then it works well for that. So back to radians. A radian is when you take the radius of a circle and stretch it around the curve. So 1 radian is when you take the radius and you stretch it around the circumference. Okay, so when you do that, you get like 1 radian, 2 radian, 3 radian, and just a touch more. So pi radians is 1/2 circle. So then a whole circle is 2 pi. So coordinates. Coordinates here, as you can see, as you go around, and they repeat, are root 3 over 2, 1/2. Root 2 over 2, and then root 2 over 2. 1/2, root 2 over 2, and then 0, 1. So how these work are, you take your your triangles, your triangle ratios. So in this case, we have our 30-degree triangle. So you have 30, and so you have 30 degrees here, right? So what you do is you take a straight line like this yarn here, you bring it straight down, and where this crosses the x-axis, you make a 90-degree angle. So then you have a 30, 60, 90 triangle. Then based off those ratios, you figure out this side, which is the x value, is square root of 3 over 2. This y value is 1/2. You get these ratios because the unit circle's radius is 1. It's set to 1. So based off that, we figure out these, and you get these two values. Now, the x value, not only is it x, it's also cosine and sine. So cosine at 30 degrees is square root of 3 over 2, and sine at 30 degrees is 1/2, right? It's weird how perfectly that works. So, and then there's tangent, right? So cosine is x values, sine is y values. Does that make sense? So for any point on the circle, cosine is x and sine is y. Now, these are the nice points. These are the nice points that are good to memorize, but every point has one. Some you just have to use a calculator for. So tangent is the slope of this line. So slope we know is rise over run, right? So if this is the origin, 0, 0, and this is your point, square root of 3 over 2 over and 1/2, then your slope is 1/2 divided by square root of 3 over 2, and then you get tangent, and then at every point you can get a tangent for it. Okay, so the trig functions, tan or cosine, sine, tangent, x, y coordinates, tan is slope. So those are all really important, which is part of how we derive them, and it also becomes. But not only that, but it relates to a bunch of other really important trig functions. So you have cosecant, secant, and cotangent, which are just inverses of cosine, sine, and tangent. But then what you also have is things like the double angle theorem, angle sum, Pythagorean identity. All those things relate to the unit circle and how it works. Like the Pythagorean identity, it's cosine squared plus sine squared equals 1. So what you have is you take your regular Pythagorean identity for triangles, 90-degree triangles, a squared plus b squared equals c squared. So if you set c squared equal to 1, and you know that this distance is cosine and this distance is sine, you square everything, right? So you get cosine squared plus sine squared equals this squared. But this is 1, and 1 squared is 1. So you get cosine squared plus sine squared equals 1, right? Which makes things simple. Okay. So, yeah, and then also relates to double angle identity and angle sum identity. Last thing is how to memorize the unit circle. Unit circle looks really complex, but there are a lot of patterns that make it much simpler to memorize. First, you start in the first quadrant, right? So you just start at 0, and you go 30, 45, 60, 90, right? And from there, they just repeat. So then you just keep adding on. So you have 120, 135, 150, 180, and then you just keep going around adding, okay? So it's very simple. More complicated things are the ratings, because we're less used to them, so they're less familiar in our heads. So what you do is you start at y, right, straight up and down. You get pi over 2. The denominator is 2 when you're vertical, so you get 2 at the top in the denominator and 2 at the bottom in the denominator. And then as you head either direction, right, it goes denominator of 3, 4, 6, and then when you get here, it's pi and 2 pi, right? So the first question's easy. It's just pi over 2, right? There's no coefficient of pi. So it's just pi over 2, pi over 3, pi over 4, pi over 6. So those you just have to straight up memorize, right? Once you get that, everything else becomes much easier. So when you move to this side, the denominator here is 2. Or not the number, sorry. The denominator is 3. The coefficient is 2. So remember that. So the coefficients are 2, 3, and 5. So the coefficient is 1 less than the denominator, right? So you subtract 1 from the denominator and gives you the coefficient, right? So as you move around, right, so it's still 3, 3, 4, 4, 6, 6. So what you do is you go 3 minus 1 is 2, 4 minus 1 is 3, 6 minus 1 is 5, right? Then you have your coefficients. Down here it's the opposite, you add 1. So you have 6 plus 1 is 7, 4 plus 1 is 5, 3 plus 1 is 4, and 2 plus 1 is 3. And this last question gets weird, but it's still possible. It's denominator times 2 minus 1. So I'll move my hand. So here you have 5 pi over 3. You multiply 3 by 2 is 6, minus 1 is 5. 4 times 2 is 8, minus 1 is 7. And 6 times 2 minus 1 is 11. Now, for the coefficients, they repeat around the circle. Their positives and negatives change. So closest to the center, like to the x-axis, you have root 3 over 2, 1/2. Same, root 3 over 2, 1/2, root 3 over 2 over 1/2. If you just think of this like a regular coordinate plane, this is quadrant 1, so you have positive x, positive y. If you think of this as quadrant 2, you have negative x, positive y. Quadrant 3, you have negative x, negative y. In quadrant 4, you have positive x, negative y. Just remember that, and you just put your negatives in, it works. So right, closest to the x-axis is root 3 over 2, 1/2. The 45, or the center angle, is always going to be root 2 over 2, root 2 over 2, right? And then your last one is 1/2 root 3.